Silicon iron representing. We are still simplifying molar concepts, and I want us to get to its end. We are actually few lessons to the end of the topic, and I'm sure each one of us is getting at least this topic simplified. As usual, I cannot forget to remind you, excuse me, about Lipal systems. Lipal systems, it is a school management site. Actually, it is a system that manages school information. It is good because it has a section where the head teacher watches from. You can monitor the school as the head teacher. You monitor everything that is transpiring in the school using this site. There is a section where the accounting system or the accounting department, the accountants and the bursars can manage their finances. You can, if you entered each of the learner in the system, the amount the learner must pay, and then you try to feed in the amount the learners paid, it will automatically update the finances of each learner and make receipts. We shall talk more about it. I now welcome the members. We welcome Max Rank is with us this time. He missed the other first one. As we wait for others, the system still manages scores. It can the system generates reports or report cards automatically. It does everything. It has a section where those can manage the academic work, and the class teachers and the subject teachers. So it is a good system. It's what we even use at our school. So we welcome the members who are joining us. Rex Frank, you will watch it. I know you will pick. Let's continue. Yes, welcome Imran to Musime. You're most welcome. Let's move on. The rest will pick from there. I want us to this time calculate using stoichiometric equations. We are going to relate everything we've been looking at, but using stoichiometric equations. This is where the application comes in. The word stoichiometric is coming from a scientific word known as stoichiometry. Stoichiometry, this is a branch of chemistry. It is a branch of chemistry. This branch of chemistry deals with actually quantitative relationship between reactants and products. In a reaction. We are talking of, we are going to deal with relating quantities. When I say this word quantities, we shall see what it means. We are going to know how to relate quantities of reactants and products in any chemical reaction. It's what we are going to look at in terms of stoichiometry. The quantities we are talking of, we looked at relating ions we're relating particles with moles. We looked at relating moles with particles. We looked at relating moles with mass. We looked at relating moles with volumes. We are going to see how masses and volumes, masses and moles of reactants and products relate. We are going to look at how mass and moles of reactants and products relate in any reaction. And this can only be obtained when we happen to write a correct chemical equation that is well balanced. We shall still look at how mass relates with volume. So what we are looking at was helping us to know how these concepts interconnect: moles with mass, moles with volume, mass with volume, mass with particles, moles with particles. So having known how these concepts interconnect or interrelate, now we want to relate them in terms of the amount of reactants and products in any reaction. It is what we shall call stoichiometry. Let me think I'm using a clear language anyone can understand. It is what we are going to term as stoichiometry. Am I clear to everyone before we continue? Shakira, you're most welcome to this one. We welcome you. You've not been part of the other one. Great, you're back from the abduction mode. Are we together, people? Should we move on? To cut the story short, I know many of us hear this word equation. We hear of the word equation. An equation is simply going to be a representation of how certain species we call reactants under certain conditions become certain species we call we call products. So in an equation, we shall have something on the right-hand side under a certain condition getting something at the right-hand side. What will always be at the left-hand side will be known as reactants. And what will always be at the right-hand side will be the products or product. A reactant is a chemical species which under certain conditions break down or combine with others to form what we call products. And the products are chemical species formed when reactants combine with others or break down under certain conditions. Let me think you do hear me, please. So reactants, we said, are chemical substances which under certain conditions are capable of combining with others or decomposing to form products. And then products will be the chemical substances formed when reactants decompose or combine with one another under certain conditions. So why am I bringing this part of equations? We shall not know how to calculate if we don't have this basic concept of writing equations. We are lucky that in the previous, those people were lucky, those who sat last year, were lucky that the equation was written. They were given a written equation. You may find that in your paper, the equation is not written but described in the question, in the scenario, requiring you to write it so that you can calculate. So to move on, we are looking at, we are going to calculate using stoichiometric equation, but this step is also crucial. To move on, let's take an example of two substances, A and B, reacting to form certain things. Let's say C and D. With O, P, Q, and R in brackets down here. I want us to learn I want us to use that example for us to try to understand the concept of equations. Welcome, Halima, and thanks for joining us. For those who are not part of our group, we say you can join us using, you can reach us using the other number 0703 27 82 31. 0703 27 82 31. Reach us, we shall add you to our group. So let's take an example of this one. We shall have equations of this nature, but we need to know how to interpret equations in words. When you are capable of understanding what the statement in an equation means, nothing will become difficult with the calculations. Let us assume we have an equation of this kind. I'm using unknowns so that we can understand, all of us can understand. In this equation, we have two chemical substances, A and B, on the left-hand side, and two chemical substances, C and D, on the right-hand side. So the chemical substances A and B on the right-hand side, they are the reactants. The chemical substances C and D on the right-hand side will become the products. The unknowns O and P on the right-hand side are the states. The states of matter these substances A and B are. And then Q as well as Q and R are also representing the states of matter the two substances C and D are. Unknown X is representing the number of moles of B that reacted with the number of moles of A. So X will always, the number influenced any substance will be the number of moles that react with a certain number of moles on the reactant side. And the same applies to this side. Y is becoming the number of moles of C that were formed with D. I want us to simplify this. The plus sign on the reactant side stands for reacts with. So the plus sign will always represent that. We are going to try to interpret that. And then the plus side, this side, on the product side, will always stand for this and or with. And or with, depending on the circumstances. Then the arrow will always represent the following. The condition for the reaction will always be put here, but the arrow will always mean that to form, to liberate, to give. This is what the arrow will always mean. We are lucky that we shall only have 3 states of matter for the reactants and products in reactions. And these states of matter will always be given as substitutes down below the chemical species in brackets as abbreviations. Where we shall have substances in solid state to be represented as S. So this means the substance is in solid state. If in solution, the substance is insoluble in the solution, if it is in solution, the S will mean an insoluble substance. That means this substance will appear as a precipitate. A precipitate is a solution with suspended solids in it. This as chemical substance may be represented as AQ in terms of state if this state is soluble. The word AQ means aqueous. This will always be representing substances that are in solution state. Substances that are soluble, that will appear as clear solutions. Or if in solid state, a substance that is soluble in water. The substance may be represented as L if it is water or a pure or concentrated liquid substance. For example, some concentrated acids like sulfuric acid may be represented as L, meaning that it is a pure liquid with very few molecules of water in it or no water in it. So it may be represented as L, which is representing liquid state. The substance may be represented as small d in terms of state. I mean here, where I used these unknowns R, Q, P, and O. If this substance is in gaseous state, they will always be represented as that. So these are the four states we shall always be using. To know if the salt is soluble or not, to exchange these ones, you must have studied solids and you must know the solubility rules. That's when you get to know that this salt is aqueous if it is soluble, or solid if it is not soluble, or if it is in solid state. So we shall talk about that with time. So we said the plus sign on the reactants side stands for reacts with. The arrow stands for to form, to liberate, to give. These unknowns Y and X are numbers that are representing number of moles. And these numbers are always put to balance the number of atoms of a certain element this side with the number of elements the other side. So any equation to be termed as a stoichiometric equation, it must have balanced number of particles, of individual atoms this side on the reactant side with those on the product side. We shall always term it as a stoichiometric equation. Let me think I'm moving with the speed we can understand. So to interpret this equation, it is standing to mean that A of state O reacts with X number of moles of B with state P to form or to liberate Y number of moles of C at state Q and 1 mole of D at state R. If we don't represent any figure here, it means there is 1 mole here, at the same time there is 1 mole on A. I think we can interpret this equation. So we may have one reactant decomposing to give certain products, or several reactants combining to give one product. So that is another alternative. Let me think I'm clear. If you have any question, please pause it before we go too far for one to pick us. If you have any question, please type it so that we cannot leave you behind. I want us to bring in stoichiometry before we go any further. But we must know this information. So if we happen to write an equation for, let's say, this one, let's take it that you want to, you're going to write for me the equation in words. So let's first talk about it before we balance it. Let's announce this one in words. For this one, this is hydrogen peroxide. This is read as hydrogen peroxide. Remember, hydrogen has a valence of 1, and peroxide is written as O2 with a valence of 2. So this is hydrogen peroxide. For this equation, in words, it will be represented as hydrogen peroxide, which is a soluble compound under UV light as a condition, decomposes to liberate, because it is one, so it must decompose. Decomposes or breaks down in presence of UV light to liberate or to give water, which is in liquid state, and oxygen, which is in gaseous state. So to make this equation stoichiometric, we must balance it. We must have equal number of individual atoms this side as they are the other side. So when we look at this, we have 2 hydrogen atoms. This side too, we have 2 hydrogen atoms. We are trying to balance this one. We have 2 oxygen atoms this side, but this side we have 1 here and 2 here. When you add them, we have 3 of them. So we can only start balancing it by making this number of oxygen molecules even, like they are the other side. To make these ones even, we shall look for the smallest even number. We shall look at the smallest even number first, which is a 2. So we shall put a 2 in front of the entire substance, not only this one, but the entire substance. When we put a 2 here, this hydrogen is becoming a 4. Remember, we have 2 this side. And when we put a 2 here, the oxygen is becoming a 2 plus a 2, which is a 4. So the oxygen is a 4 this side, and the hydrogen is also 4 this side. So to balance it, we shall also put a 2 here, such that the hydrogen becomes a 4 as it is for this side, 2 times 2. When we put a 2 here still, the oxygen will become a 4 because we shall multiply the 2 with the 2 to get a 4, as it is 2 plus a 2, which is also what? A 4. So now the equation is well balanced. To read it again, it will be 2 moles of hydrogen peroxide or 2 moles of soluble hydrogen peroxide under UV decomposes to give 2 moles of water in liquid form and 1 mole of oxygen gas. In words, if we are to look at it, we must know that information. Sorry, Derek, for being late. Kevin is also late, sorry. But we are great that you've joined. Let me think we are flowing for those following. If you have any question, before you go any further, pause it. Pause the questions, please. Nanyonjo Shakila is with us. Pada is with us. Halima, Jimbo, you're most welcome. This is my first time to see you. Imran is asking for the number. The number is 0703 27 82 31. You can even watch the video again to know the number. You're most welcome, Delik, though you're late. Kevin, you're most welcome. Maybe we can move on. So you can even share us with your friends. You can share our videos with your friends. Let's try balancing this one together. Yes, I've said we can only know that the compound is aqueous if it is soluble. And the solubility of substances is determined by certain rules we saw. The solubility rules are in this topic of solids, if you covered that topic. Let me think. I'm responding to this someone who has asked, how do I know? Pade Shavuf is asking, how do I know that the compound should be represented as AQ? You must know the solubility rule about it. We know the solubility rules. They are about 7. We shall talk about them. Let's assume magnesium, this is an insoluble solid in water, reacts with, or magnesium in solid state, reacting with nitrogen, which is a gas, giving magnesium nitride in solid state. So someone to try to balance this one. Try balancing it there. So when we look at this one, how many magnesium atoms do we have this? We have 1. The atoms in the chemical species, we have 1. How many magnesium atoms do we have this side? We have 3. So how can we try to balance this one? When we put a 3 here, will the magnesium balance? Yes, we have 3 magnesium atoms this side and 3 this side. How many nitrogen atoms do we have this side? We have 2. How many do we have this side? We have 2. This means this equation is as well balanced when we put a 3 there. So Imran had already told us we just put a 3 on magnesium. We are grateful. This time Fiona is silent. I don't know if she's with us. Fiona, are you with us? Say yes or not. Nanyenjo Shakira, thanks. But do me, I'm not getting you. Sodium nitrate. As in what? Tell me. Great Nachito Sania is with us. She has joined. The equation is already balanced. Thank you. Nachito Sania has balanced it well. Try to balance for me this one before we go any further. Let's start with a simple one such that we can have everyone on board. Reacting with oxygen, which is a gas, forming copper 2 oxide. So this is we are starting with a simple concept. Jimbo, sir, is the equation which can, is there any equation which cannot balance? Any equation that cannot be balanced, it is a wrong equation. All equations that are right can be balanced. Whenever you find an equation that you cannot balance, just know that equation is wrong. That was a question from Jimbo. Is there any equation you cannot balance? No. All equations that are right can balance. Let me think I've answered Jimbo. And I'm sure you've all balanced this. I'll put more examples as you also try to balance them. As you are balancing them, still don't forget to describe them in words. You should also be good at describing equations in words. Let me give you another one. Whoever tries this will be a great veteran, will be given a medal of honor. Okay? From Muto. So balancing this one was a matter of putting a 2 here such that we balance oxygen. We have 2 here and 2 the other side. We had 1 this side. So when we put a 2 here, the oxygen atoms will balance with the 2 to this side. But the copper has got a 2, which is not this side. So we can only balance it when we put a 2 there. So the equation is balanced. Let me think I've done it. how do you get the valency? This is from Faustino. Faustino, that was the introductory part of this topic. We are going to share the video in the group such that you know how to generate chemical equation, chemical formulae. Yes, Faustino, they will share with you about this. Try to balance for me this one. It is a lengthy equation. It is aluminium sulfate reacting with sodium hydrogen carbonate to give aluminium nitrate. Sorry, this is a 3. The states here, this is aqueous. Sodium hydrogen carbonate is also aqueous since it is a soluble solid, to give aluminium hydroxide, not oxide, not nitrate, hydroxide, which is hydroxide, it is an insoluble salt, plus sodium sulfate, this is a soluble salt, since it is a salt of sodium plus carbon dioxide. So write this one as a single line, which is a gas. It is a single line. Don't break it like I've done. Let's try to balance this one. We get a medal of honor. Try. When you happen to balance this one, we shall be coming on to board. Shall be getting close to our target. Please try to balance that one. I don't see Fiona. I've not seen Zahala today. Are we trying? We are depositing so that you can. Are we trying? Who has finished it? I know it is a tug of war. It is a tug of war to balance it, but let's try. It is the teaser for the day. There is a medal. You just balance it well. There is a medal for that. Whoever does it will be a Muto online veteran for the year. As you're struggling with balancing that one, it cannot stop us from continuing. We are trying to simplify. So has anyone tried to balance it well? Maybe we'll take a snap of where you've balanced the equation from and maybe post it in the group, the WhatsApp group. We said if you're not in the WhatsApp group, try us on 0703 27 82 31. You'll try us via that number. We shall add you automatically to the group. Let's continue. Let's now try to calculate using stoichiometric equations. For one, to calculate using stoichiometric equations, if you want to calculate using stoichiometric equations, the balancing numbers are very crucial. The numbers before the chemical substance or before the chemical species on the reactants and the product side are very crucial. We are now going to bring the other concepts we've been looking at into equations, but the equations must be stoichiometric equations, must be well balanced. They must be well balanced. You never know, one day they may bring an equation in word form when they want you to write it in formula form, and then you balance it yourself. So you may have some examples. Let's start with this one. We shall have some scenario questions at the end of the chapter that are problem solving to simplify this concept for you. Determine the volume of oxygen gas that is required to form 38.4 grams of, let's say, iron 3 oxide when iron is completely heated in air. Let's have Paddy. Wow. Paddy has tried. Paddy has balanced it. Paddy deserves a medal. And please, I know you are good WhatsApp users. There are medals. Can you please deliver the medals to Sebuf? He has balanced it first. Can you please send the medals to Sebuf, as many medals as possible, as you are also trying? I know you will figure it out. Please send the medals to Sebuf in the group and here. Send the medals. Sebuf has passed it, has balanced it well. Thank you, Sebuf. Actually, Sebuf, where is your school? Tell us. And what is your school? Sell your school. We've given you a platform. Sell your school. Tell us. There's an item here. Please, let's come back. There is an item there. So Sebuf is schooling from Machinge Secondary School. Send gratitude to your chemistry teacher. He has done a good piece of work. Balancing equation is a tag of what most of the learners, if you can do that, thank you. But it is simple knowledge. There's no much chemistry there, people. Balancing equation is the simplest. And if you need questions or equations to balance, you can ask for them. We have as many as we can. To move on, we can try this item here that determine the volume of oxygen gas that is required to form this amount of iron 3 equation. Iron 3 oxide when iron is completely heated in what? In air. So they are bringing in a condition which is heating. This may need you to first write an equation, assuming this question is not giving us the equation. In most cases, they may give us an equation. Given an equation, so iron is in solid state. When completely heated in air, so it will react with oxygen. The condition is heating. It will giving us iron 3 oxide. This is in solid state. So we can try balancing it. When we happen to put a 2 here, when we put a 2 there, the oxygen, why are we putting a 2 here? To make oxygen an odd number. It has a 3 on it. So we want to put a 2 here because it is the smallest even number. To make this 3 an even number, such that we can balance the equation well. But when we put a 2 there, the oxygen becomes 6. Yet we have a 2 this side. So how can we make this 2 6 such that the number of oxygen atoms this side balances with those of the other side? We shall put a 3 here. But putting a 2 here made iron to become a 4. So it can only balance by putting a 4 here. So the equation is fully balancing now. Basing on the question, what they want us to use, we can have a bracket. A bracket, we can have iron as 56, oxygen as 16 in the brackets. So they are asking us to determine the volume of oxygen gas at STP. Let's add this one. At STP, we can also give this one, that 1 mole of a gas occupies 22.4 liters at STP. So you see this, we are bringing in the other concepts, but this time using stoichiometric equations, using well-balanced equations. For one to calculate such numbers, must know that the introducing statement must be relating product reactants with products. And in that, we shall always start by rewriting the equation if given, and if not given, we shall always start by writing the equation, balance it well, so that we can use it for calculations. From the equation, it is stated that 4 molecules of iron reacts with 3 molecules of oxygen to give 2 molecules of iron 3 oxide. But basing on the scenario, they want us to relate only oxygen with the product, because the mass they gave us was of the product. And the question is asking for the mass, for the volume of oxygen at STP. Let me think I'm flowing. If we are asked to calculate for the mass, this means that from our previous things, the volume of the volume they are asking will be on the right hand side, and what we have will be on our left hand side. So we have the mass of the product. That means we shall have the product on the left hand side and then oxygen on the other side. So this means from equation, this will always be your statement. From equation, if we are calculating using stoichiometric equations. So from equation, we shall start by relating number of molecules of what we are asked to use. We are asked to use this one and this one, but this is what they told us to calculate for the volume of this. So this one will be on our right hand side in terms of the statement. From equation, 2 molecules of what? This time of iron 3 oxide. What are they telling us to relate it with from the question? They're telling us to relate it with oxygen are formed from how many molecules? You come back to the equation. What was the balancing figure? It is a 3, formed from 3 molecules of what? Of oxygen. This statement is very crucial in your calculation. This statement is very crucial. So whenever we are going to look at any quantity in line with iron 3 oxide, we shall relate it with these 2. We shall multiply it with these 2. Whenever we are going to write about any quantity of oxygen they asked us, we shall multiply it with these 3. We are calculating using stoichiometric equations. Since they told us to relate mass for this one, they told us about mass from the scenario. And for oxygen, they talked about volume. Remember from the previous concepts, we relate standards with standards. That statement should be in your heads. We relate standards with standards. Since we are given mass here for this, we shall look for the standard mass because we shall relate standard mass with the standard volume for oxygen. The standard volume, we are lucky it is given 22.4 liters. Now we need the standard mass here for this one. So the standard mass of anything is the molecular mass. So we shall calculate for the molecular mass of the iron 2 oxide. We know the formula, the iron 3 oxide. So it will be iron, which is a 56, times the number of iron atoms in the formula, which is a 2, plus the atomic number of oxygen, which is a 16, times the number of oxygen atoms in the formula, which is a 3. So we shall have a 112 plus a 48. What did we get? Are getting? So people are getting 160 grams. So remember we said this is the standard mass we need to use. And we said we calculate using first principles. First principles means using statements, complete statements that have a logical flow. So from that statement and the previous statement we made from the equation, it is indicated that, remember we are now relating standards with standards. We want the volume. It is indicated that previously we had two molecules of oxygen reacting, of iron 3 oxide, being formed from three molecules of oxygen when reacted or heated with iron. So this means the standard mass is 160. So we shall have 160 grams, but multiply it with the number of molecules we talked about for iron 3 from the equation. What are the number of molecules of iron 3? They are 2 molecules times 2. And these are grams of iron 3 oxide were formed from, what did they ask us from the question they asked for volume? We are relating standards with standards. We are formed from what? The standard volume, which is 22.4 times the number of molecules from the equation. How many molecules of oxygen were used? 3 molecules times 3. What we get, they are liters of oxygen when heated with iron. Write a complete statement. So how about 1 gram? For 1 gram of what? Iron 3 oxide. We are calculating using stoichiometric equations. So 1 gram will be formed from the 22.4 times 2 divided by the 160 times, no, this is times 3 times 2. We are sorry that you've not been hearing us. Sorry. Sabuf, let me think you hear me now. Rank, let me think you hear me. And everyone, do you hear me? Do people hear me? Do you hear me, Sebufu? Do you people hear me? So I've been saying that this introductory statement relating number of molecules of reactants with products from the equation is very crucial in stoichiometric calculations. Very crucial. Know what they are asking for and look at what they are given. The other information is, the other concept we are looking at does not change. The concept of relating mass with moles, number of moles with volume, number of moles with mass does not change. But relating the number of molecules of reactants with the product, following the rule that what is given is what goes on the right, on the left, and what you're calculating for goes on the right is also crucial. Don't forget to relate standards with standards. We relate standards with standards. Let me think I'm clearly speaking. Am I clear, people? Sanya, do you hear me? Sanya, I know you'll pick me. Maybe you joined us late. To move on, I'm going to give a question here, and you're going to calculate it for me and put the answer in the group to check your level of grasping. You're going to try for me this. You're going to try for me this. So this becomes this 6 this side. You're going to balance this equation for me. You're going to balance it for me. Write it. You're going to balance it for me, then write answers. You'll balance it, I know. You are good people. You're going to calculate, you're going to do for me these ones. So you're going to determine the mass of lead 2 oxide formed when when 36.5 grams of lead 2 nitrate are strongly heated. You're going to get for me the number of moles, number of moles of oxygen gas liberated when 106.5 grams of lead 2 nitrate are heated. Please, we said we shall start by balancing this equation. Don't forget to balance the equation. Start by balancing the equation. And C, we shall calculate for the volume. We shall calculate for the total volume of the gaseous products liberated when 55.2 grams 55.2 grams of Led2 nitrates are strongly heated. So you can take the bracket what? Heated, strongly heated. Are strongly heated at STP. In a bracket, lead is given as 207. Nitrogen is given as 14. Oxygen is given as 16. Then 1 mole of a gas occupies 224 to 22,400 cubic centimeters at STP. So you try to calculate to do for me that item as I entertained some questions before. We call it a day. You can first get the number of moles, then get the volume from the moles. That is okay. Please, Halima, if you're not part of the group, you said reach us on the number 0703 278231. And then for that, you'll be able to get us and you put your calculation on paper for display. Well, we can see you. Then there is another question here. I requested that you explain again. Maybe Rex Frank, you rewatch the video. That's why we always post them after. Where are you lost? Where are you lost? Where are you lost? Thanks, Frank. Where are you lost? So that I can pick you. Maybe this is Nachito Sanya. Yes, to which question was that answer, Halima? Which question am I calculating? You may be behind, Halima. You tell us. So Halima is getting 8 point. Halima got 8.064 liters here on this previous calculation. That's the answer she got. Do you have any question before we continue? Do we have any question before we continue? Any question? Any question, please? Any question? Any questions, please? Maybe we post the questions in the WhatsApp group so that we can get some responses. Thank you. Teacher Alan, Muto Online. Kali.